Dial peer, wildcard, and voice route matching. Well, if you're coming out of the previous nugget straight into this one, you have some powerful tools in your tool belt already. You have the ability to route calls between dial peers on the same router. They call this a local call, if you will, between two local POTS directly connected devices. And we even talked about setting up voice over IP dial peers and setting up calls over an IP-based network between those. And that's great, but you run into limitations of scalability. I mean, if we have extension 101, 102, 103, you don't want to have to create a dial peer that says, here's how you reach 103, and here's how you reach 102, and here's how you reach 101. I mean, expand that to a corporate network with thousands of phones, and it just becomes mayhem, much less creating a dial plan for the PSTN. That's the purpose of this nugget. We're going to get into wildcards and voice route matching, describing, number one, the wildcards that you can use in your dial peers to make it easier for yourself. Then we'll get into the matching. And this is what we started getting into in the last nugget, I would say by mistake, when I pulled out a UC520, not realizing it doesn't do the default dial peer. But we'll look at the inbound and outbound matching of dial peers, what this default dial peer is, and then this is my debatable one. I have a feeling I'm going to break this into its own nugget. What I want to do is put it all together, and let me take this moment to build some enthusiasm in all of us, and that is by the time we're done with this nugget, we will be able to put together a complete PSTN routing plan for our router. And I mean, let's just see where we are at this point. We could bring up a T1 line. We could bring up some FXO ports to the PSTN and have a fully working voice over IP calling network. That's going to be the end-to-end communication. I have a feeling I'm going to put that into its own little spot. Well, for now, let's dive into the wildcards. Now, these apply directly under the dial peers. So, for example, we've got our router, our voice gateway that's connecting maybe up here to the PSTN. And then down here, PSTN. Then down here we have a connection over here to Office X where we've got extensions 1XXX, anything starting with 1. And over here we've got extensions 2XXX. So what I'm saying is we don't want to have to create individual dial peers for each extension over there or each phone number on the PSTN. That's where these come in. So let me hit the most common ones first and I'll break it down from there. First off, the dot. We've seen that in one of my previous nuggets, but let's mention it now. Matches any single digit. So, for instance, in this little scenario up here, 1 dot dot would match 1 in any 2 digits, or 5 dot 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 would match 5 in any 3, or 5 1 dot dot 1, or so. You can get as creative as you want with it, but really the period is a single digit. Now this is where this one is very commonly used and gets confusing. This indicates a range of numbers. So, give you an example. I could do a 2 through 9 bracket 1 1. Now what that does is match any digit that is 2 through 9. So for example, 2 1 1. 3 1 1, 4 1. You get the idea. Any one of those would match. Now, where the confusion comes in, the reason I take some time to explain that fully is because sometimes people go, well, does that match like if I did 2 3 4 1 1? Because 2 is in there, 3 is in there, 4 is well, yes, but this only represents one digit. Whenever you are in the bracket world, it always represents one digit. So for example, maybe you've got a remote office with 1XX, well, I don't want to overlap here. Let's say I've got 1XX and 3XX extensions over here. I could actually do, and let me show you a little trick already. You could do 2 through 3 dot dot, or I could even do 2 3 dot dot. The dash in this case would be optional. Now, I know you might be looking at that and going, whoa, wait a sec, 23 dot dot? No. Don't read it like that. If you ever see digits next to each other in the brackets, mentally, don't type it in, but mentally put a comma in between. See, the Cisco iOS realizes it's only one digit inside of here, so it knows it's not 23, so it automatically says 2 3. Well, I say, well, why would I do? I mean, this just makes much more sense. Well, what if? Let's do this. What if I was? Oh, wait a sec. I did this all wrong. I actually had the perfect scenario. What if I have extensions 1XX and 3XX sitting up here? right? I don't have two or 3. So I can't do 1 through 3 because that would also include 2, right? I could do 13 ... Well, that's not the way to say it, but you get the point, right? 1 or 3 ... extensions are available over there. You can even do nice little combos. I could do 1 through 4, 9 ... which people might read as 1 through 49, but really it's 1 through 4 and 9 and any 2 digits after that. Does that make sense? That's a weird one, I know. Now, what about this? Negates a range. This is an everything but. So for example, we'll see an example later on where we're creating a PSTN dial plan where we say 9 bracket 1 bracket ... We're creating a dial plan for the outside one. So we're saying 9, and then this digit after 9 can be anything but the number 1 would fit into there. So, it could be 0 through 9. Well, wait a sec. 0, comma, 2 through 9 would fit in there. And even the little asterisk, that a lot of people forget about that on the telephone keypad, would fit in there because it is a valid digit, but it's not a 1. So that would be an option. Now, let me hit T. T is the ultimate dial string. It matches anything. So if I were to create a dial pair and I say destination pattern T, that matches anything from 0 to 30. I think it's 31 digits in length. Now, the problem is, how does the router know when you're done dialing? Right? So let's say I've got a connection to the PSTN. I have a phone on an FXS port, and I create destination pattern T going to the PSTN, which is a real easy way to say send everything to the PSTN. That's fine. But I pick up the phone and I dial, okay, I want 9 for an outside line, 480-111-5121. And I sit, and I'm like, well, I'm done dialing, and the router waits, and it waits. It's actually going to wait by default for most iOSs is going to be 10 seconds. Now let me tell you, when in today's modern rush world, 10 seconds feels like an eternity when you're sitting there waiting for the phone to go brrr and ring. So the 10 seconds is called the interdigit timeout, to where it's waiting, it's assuming you're going to dial more digits until it finally times out after 10 seconds. So that's not good. T is good when you're doing like international dial plans for numbers that just aren't common, numbers that you don't know. But you'll find out later on, it's very easy to create your own PSTN dial plan once you get pretty skillful with these other wildcards. Pound indicates end of dialing, and I would say it's optional. You don't have to put it in there, but you could. So for instance, I could do T pound as one of my destination patterns. So that's a way to overrule that interdigit timeout. Let's say I'm done dialing, I can just hit the pound key after that and immediately process the call. Truth is, the router will do that every time, whether it's in the dial plan or not. Last one, I kind of skipped over it because it's kind of a nonsense dial card, a wild card. You can put a plus at the very beginning of the destination pattern or at the end. It doesn't mean anything. It doesn't. I shouldn't say mean. It doesn't do anything. It's more of like a note. This is a E164 valid number, meaning it adheres to the E164 standard. So you go, well, what's that? Well, the powers that be, when they got together and said, well, these are the numbers that work worldwide on our public switch telephone network, they called that the E164 standard. So if this number matches that standard, you can flag it to say this is an E164 valid number. But honestly, in a production router, I've never seen that used. It's just one of those things that might be in a reference book somewhere. Well, it'd be great to look at some examples of these with you. So let's look at some example destination patterns. So I've got a router sitting here to whatever mystery network I'm connected to. And I do destination pattern 1, 2, 3, 4. That's easy. It matches exactly that destination pattern, 1, 2, 3, 4, and goes to whatever that means. That's an easy one. Now, the reason I throw that in there, I know that's nice and logical and a nice easy start, is because I want to bring up a characteristic right now of POTS dial pairs. POTS dial pairs automatically strip any explicitly defined number. Let me say that again. POTS dial pairs automatically strip any explicitly defined number. So here, let me give you the why behind it, and then I'll tell you what it means to us. If I've got, let's say, a connection to the PSTN right here, Cisco knows that most people define an access code, like a 9. Like I'm going to dial 9 on my telephone here to signal that I'm reaching for an outside line. So they said, well, we'll allow you to create a POTS dial peer. Let's say this is an FXO port or a T1 line going to the PSTN. You can create a POTS dial peer that says 9 ... I'm doing North American numbering here. ... Those are 10 dots. Going right here, which is 10-digit dialing inside of the North America. So Cisco says, well, the great thing is, if you create a POTS dial peer, this is an explicitly defined number. Like you typed in the number 9 in your destination pattern, so I will automatically strip that. It's gone. Should have used a bolder color here. Stripped. It's gone. It's torn off before it actually sends it out because that's internal. The PSTN doesn't want to see that leading 9. Now, what that also means is maybe you've got, another dial peer. Here going to the PSTN, where you have 9-1, which is long distance, ... whatever number of digits after that. Well, it's automatically going to strip the 1 off of there. So you may have to put some commands on there to keep those digits. The command is actually 4 dash digits, and you can tell it how many digits it should forward. Or you could even do a no digit strip, which turns off that automatic feature. But more on that later. I just wanted to add in that side note as we're talking about that first destination pattern. So here's another one. 12 ... 5. That is 12 as the first 2 digits, any 3 digits, and then 5. So a 121115 would match that. 129515 would match. I mean, you get the idea, right? So right here, we've got 1, 2 through 8. So this is going to be 1, and then the second digit must be 2 through 8. And again, it's not going to be 2, 3, 4. That's not what that matches. This is 1 digit. So I would say this would match 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 digits after that. So 5, 5, 5, 1, 1, 5, 1. Okay, so that would be is that 2? There's 9. Hang on, 5, 1, 1. Well, however, you get the idea, right? The dots are whatever. So what would not match that would be a 1, 0 something or a 1, 1 something because they're not included in that range. Okay. Nope. Yeah, I know some of you are looking. You're going, well, I don't. What's that? Sorry, I meant to put a caret in there. I just forgot. So caret 9. This means anything but 9. ... So 8, 1, 1, 8, 5, 5, 7, 6, 2. Anything but 9 would match that. Now we come to some of them that might be, it's like a certification question. It's like, how non-real world could you go, right? Okay, 1, 1, 2, 4, dash 6, 1. What is this? This is 1, 1, and you guys are with me on this, right? Mentally insert a comma because they're next to you. It's not 24. We know it's only 1 digit, so 1, 1, 2, 1 would match that. 1, 1, 4, 1 would match that. There's no 3. It's not included there. 1, 1, 5, 1, 1, 1, 6, 1 would match that because that's the 4 through 6 right there. So those are all valid options that we could have for that one. Now, I will say I was mentioning certification exam. I have done funky things like that in the real world. There's a gamut of whacked out dial plans that you'll run into in the real world. So be prepared. I mean, when you have to realize when you sign up for a DID block, meaning the PSTN carrier says, here's some numbers that will go directly into your company. Like you get 480, 555, 11, 51 through 1159, and then they might throw in there, oh, and you also get 480, 555, 3362. And so you end up with a dial plan where somebody, the previous, normally I would translate that. I would say, okay, if somebody calls that, it's actually going to go into extension 1160 or something. But some people carry that straight through, so they have all these phones on the inside, or this one is extension 1151, 1152, and then over here you got this weird extension that's 3362, and at that point you start having to create dial plans that are just kind of wacky. So I've seen all kinds of crazy stuff. So don't throw it out just because it looks like you'd never use it. Last one. This is the ultimate dial plan, 9 and any number of digits. Again, I believe it's actually 0 through 31 or 32 total digits that it would collect, so you can actually just keep on dialing and it would keep collecting digits. Also, something I want to mention right now, if you ever start getting into the documentation of Cisco, you'll see a lot of examples like this where they'll have a dial pair going to the PSTN. Let me switch over to green so it's unique. They have a dial pair going to the PSTN, and you'll see it as .t will be the pattern. You see that all over the place in the Cisco documentation, but they never tell you, well, what's the dot for? Let me explain that. The dot is to require at least one digit, right? It happens all the time. You lift the phone at your desk. Meanwhile, your boss walks by and it's like, "Oh, Jeremy, did you get those TPS reports?" You know, and you're like, "Oh no, I'm gonna get those to you. I swear, I just got to work a little bit on." Meanwhile, you're holding that handset in your hand, right? The interdigit timeout is reached, and it goes to place a call. Well, if you just made this a T matches 0 digits. So automatically your phone goes out and seizes a PSTN trunk even though it hasn't dialed anything. And what you hear, or maybe you don't hear because you're talking to your boss, is it flips over to a different dial tone. It goes, Yeah, I mean, it's just a little interruption there in the middle where it went from the internal dial tone generated by the router to now something that's being generated by the PSTN. So the dot requires you to at least dial one digit before it's considered valid to match that. Now that we've seen the wildcards, let's get into the inbound and outbound dial peer selection. So this is when a router receives a call and he's got multiple dial peers, which one should he use? So for example, maybe I've got a router right here. Got my phone just connected for simplicity on an FXS board. I've got, we'll call it PSTN connection number 1. I've got PSTN connection number 2. Two different paths that we could go. So this guy, I create dial plans that says, 9T goes out that way, and maybe 9480 ... goes out this way. It's kind of like a 10-digit dialing string. So this guy picks up and he calls 94805551212. From the router's perspective, he now has an overlap. He's going, okay, well this matches, but so does this. That's kind of a match anything. So which do I choose? Well, the default search order is this. Now I'm talking outbound dial peers. It's going to say, number 1, I want to go with the closest match. So I'm looking here, 9T. Well, that's really broad. I mean, think of that as like that's infinite number of strings that it could match. Whereas this one, I mean, there's only 999,000 strings that are possible. Something like that. That's in those dot, or would it be a million? Because zeros, I don't know. But you get it. It's a finite number compared to an infinite number. So in this case, in this example, this one wins. It's the closest match. Now, what's this? Explicit preference. Well, this would happen if the matches were tied. So maybe over here I don't have 9T. I actually have 480 ... 9 in front of it, right? So they're identical. They're duplicate dial plans. In this case, it's going to look for something known as the preference. Now let me jump over to a live router and show you this. I'm on router 2. Let me do a show dial peer voice summary. You can see that I already have a dial peer for 102. Now I could go in and I could create dial peer voice 103 POTS, and I could say the destination pattern for this guy will also be 102. It's going to go out port 1/0/1. Oh, wait a sec. 0 / I'm on the UC520. So 0/0/1. So wait a sec. Let's go look here. I'm going to have show dial peer voice summary, and now I've got not 1 but 2 destinations to 102. Now you notice that one of the things that it's kind of wrapping around, it says prefer. These are set to 0 by default. The preference, let me show you, is a value from not caps lock, question mark, from 0 to 10, so 11 possible preferences that are there. 0 is the default, where lower numbers, unlike logic would dictate, lower numbers are the more preferred than the higher numbers. So if I were to go in here and say, well, this is preference 1, go back and do that same command, now this one will always be preferred over this one, because it's a lower preference, or think of it as a better preference. Lower preference doesn't sound as good. So we could do explicit preference, and that would say, well, this one is, maybe 0, it's more preferred, and 0 is the default than this one because it's a better connection, maybe cheaper or something like that. Now, what if you saw when I first did this, the preferences were initially tied, and if it's like, okay, destination pattern is a tie, preference is a tie, it then resorts to random chance. It's going to just pick one out of a hat. Truth is, it's going to try and do kind of a little round robin-y sort of thing. But you can change this. Most people don't, but you can. I could go in and do dial peer. One of the options is hunt. And by default, 0 is what it uses. Longest match and phone number, explicit preference, and then random selection. But I could also change. I could say explicit preference and then least recent use. Maybe I want to do kind of a little load balancing that way. Or, I want to say, well, you know what? Explicit preference is the one that rules, then the longest match. So you can change it around if you want to. But I would say, I've always kept it on 0. That's the default and almost always what you want to use. Okay. So that's the outbound matching. What about inbound? That means I'm receiving a call, and I have multiple dial peers that do certain things. Which one is it going to match? Well, what we have here is a list of 4 steps that the router will take to get that inbound match. Now, I still remember back when I was first learning voice over IP, the inbound dial peer was really a confusing topic to me, because I was like, well, I'm making calls. That's what I'm doing, is I'm placing calls outbound on my router. I don't get this inbound. Well, remember, the router has to have a call leg that defines the action to take for an inbound call. And when I say the action, I'm talking about the features to use, the codecs to use. What does it have? Voice activity detection. Where's it going to send this call? All those kind of things has to be matched as I receive calls. So imagine with me, we have a router. It's connected to the PSTN. A call comes in on that port. The first thing it's going to do to try and find an inbound match for it is say, do I have a dial peer where it matches a feature called the incoming called number? Meaning I can go here. Let me go back under one of my dial peers. I'll do incoming called number. You can see I can type in whatever value I want. What that is trying to match the DNIS string that was sent by the carrier. Simple enough, right? Okay, I give. What's DNIS? It's the Dialed Number Information Service. Now, for those of us that maybe are setting this up in a small office or a home, we have FXO ports. We don't get DNIS on FXO ports, meaning our FXO ports just realized that they got an electric charge. The PSTN shocked them. That's how they know to ring if you're a phone, or that's how the router knows to answer the call. But it does not know what number somebody dialed out on the PSTN to actually get to that FXO port. You follow me? I'm not talking caller ID. Caller ID is called ANI. Automatic number identification. So on FXO ports, we do get ANI because that's how we're able to tell who is calling. That's our caller ID information. But on FXO, we don't get what number they actually dialed to get to us. We get that on things like T1 lines. Like maybe we've got our PRI circuit that is going to the PSTN. When somebody calls and they say, well, I'm going to call 555-1212, the PSTN gets that, carrier gets that, and routes it over to us. We will actually receive via DNIS that they called 555-1212 to get here, and then we actually see their caller ID. They are 9621563. Just a random, nice, made-up number there. So that would be their caller ID or ANI information that was coming in. So coming back to here, the very first tie-breaking way that it's able to make a match is by using incoming call number and then what number I want to match. So if I'm saying, I want to match when somebody calls this, treat it this way, route it that direction, all that kind of stuff. Second thing is if I type in the answer address. So again, back on the dial peer, I can go underneath here and type in answer address, and then what is the number. So I can go in here and say I want to match the ANI information. Again, now we're in the caller ID for these certain values. Like I want to match, if it's this person calling, do something with them. Now I know right about now you might be thinking, this is crazy. Does this really matter? I mean, come on. Why do we care about somebody, matching somebody's caller ID and saying, here's what I want to do with it? Well, let's play it out in a big picture scenario. Think of a corporation who has decided to centralize all of their voice services into one data center. Like all the calls go into one place, and they actually have banks of people. Some people on the East Coast US, some people on the West Coast US, some people living in Hawaii, some people internationally in India. We've got people scattered all around the world, and based on what number they're calling from, maybe we break the telephone numbers into the time zones. Based on what number they're calling from, we route them to a certain bank of people. Real world scenario. So where now we can say, okay, well, anyone coming from, I don't know, 480, that's Arizona. That's going to be routed over here to the West Coast region, and the West Coast sales team will be able to answer that within the normal hours of service. That makes sense. So that's something we could do. If it fails, if it hasn't gotten any match here, it's going to try and match the destination pattern. It's going to say, I'm going to compare the caller ID to the destination pattern configured on there. So again, maybe I've got 9512, whatever as the destination pattern. It's going to compare the caller ID and say, do I have a match? If so, that's my incoming dial pair. And then finally, if all those have failed, it's going to resort to the port assignment, meaning maybe the FXO port was 0/0/0, and I have a dial pair for some reason associated with 0/0/0. It's going to match that dial pair on the inbound. Now again, this just gives us the settings for the connection. If none of these match, and you're not using a UC520 like we saw on the last nugget, it will resort to number 5, which I don't have listed, which is dial peer 0. I don't know why, but every time I think of dial peer 0, it's just like this despair dial peer. It's just like the land of lone, something where it's just been abandoned. Like I don't know why. It's just, I just feel like forsaken every time I talk about dial peer 0, because it really is the match of no match. Meaning, if all of those things did not succeed on the inbound, it's going to match the default dial peer 0. Now, this is a dial peer that you cannot configure. So even if you wanted to, you can't go in and tweak its settings. It works for any codec, and you might say, well, that's a good thing, and it is. So whether I'm using G711, G729, ILBC, any one of those codecs coming into the dial peer, it's going to be like, hey, welcome home. You can come on here if you're using that default dial peer 0. Again, meaning you don't have any way of matching using those 4 things that we have before. So it works for any codec. It has VAD enabled. Now we start getting into some of the drawbacks. And you can't change this setting. It's the default setting. It has VAD enabled, which stands for Voice Activity Detection, which says if you stop speaking, meaning let's say this person is silent, they're not speaking, I'm not going to send bandwidth. You might say, well, isn't that good? Well, yeah, most of the time, but sometimes people don't like VAD. If your router's overloaded, or it has a decent processor load, or it just is a slow router, sometimes VAD doesn't keep up and it starts cutting off the first syllable every time you start talking, because VAD has to turn on, it has to turn off when you start speaking, and if it's not fast enough, it's going to start clipping the individual syllables when people first start talking. So you might want to disable that guy. It marks traffic, and we haven't gotten into any of this stuff. These are quality of service settings. Quality of service is essentially null, meaning did you hear that? That would be failed quality of service, a dog barking in the midst of my recording. So no quality of service is essentially what this means. We've got traffic marked as IP precedent 0. There's no quality of service allowed, and we can't adjust that. And now I should say IP precedent 0 is no marking, kind of best effort, and it does not accept RSVP. One of the quality of service mechanisms we'll talk about later is the reservation protocol, to where I can reserve using RSVP certain amounts of bandwidth through the connection to make sure or guarantee that I get high level of quality of service for the individual phone call. It doesn't do that with the default dial peer. Finally, it supports fax rate service, which means it can handle faxes coming in over that dial peer. The big picture is you don't want to use the default dial peer 0. You don't want it to automatically match that one because you want to have a complete end-to-end dial peer configuration that makes sure all the right settings are applied. Okay, so what did we see and what do I want you to do with that? This is actually a really important section here. We saw the different wildcards that we can use. We saw the inbound and outbound matching, the policy that it uses when it has, for instance, overlapping dial peers. When it receives a call, how it handles that, looking through that list of 4 things like the incoming call number, the answer address, looking at dialed number, DNIS or ANI information, and then making the correct match. And we saw also the default dial peer 0. Now, the bigger question, what do I want you to do with this information? Well, at this point, I'll just clear off the slide there. At this point, you now have enough knowledge to create an entire PSTN dialing plan. So I would encourage you, if you have a lab router, to do this. If not, grab a piece of paper and write up some digits. For example, and that's where I'm going to go in this, I'm going to create a nugget called end-to-end communication, where we set up a complete end-to-end scenario where we actually can receive inbound calls, we can place outbound calls, and I'm going to bust out my cell phone and make that ring. So in the meanwhile, I want you to start brainstorming. Okay, what does it look like? I've got, what we're going to do in this next section. So I'm going to take my home phone line, disconnect it from my home phone, and plug it into the FXO port from the router. So I'm going to have the PSTN coming directly into that FXO on my UC520. What dial peers should you create to do this? And I will say 9T is not an option. I don't want a 10-second delay, nor do I want to tell all my users to dial pound when they're done dialing to do that. So what would be some dial patterns that you would put there? How are the incoming calls going to be matched? How do I make sure that I get a good valid match on my incoming dial peer from the PSTN? Another big one, and actually we haven't talked about this one yet. I'm going to talk about it when we get into this end-to-end communication. How do I, when I receive a call on the FXO, we know that it doesn't have DNIS information. By the way, you'll want to know what those acronyms mean. Same thing with ANI. It does have ANI, which is caller ID, automatic number identification. It does not have DNIS, dialed number information service. So I don't know what number it was called. So what does my router do with it? Well, really, I mean, my router just got a call. It's going, it lifts the handset, but it's supporting, what, 50 phones back here? 5 phones, 10 phones, whatever? How does it, I mean, what's it going to do? Is it going to say, well, you're the first phone, so I'm going to route it to you? I mean, what do you think? I mean, just brainstorm that. We'll answer that in the next nugget. But think that through. See if you can figure that out, and then maybe see if you can think through how to change that. Maybe do a couple Google searches on that. So, last thing we talked about, default dial peer 0. I would know, again, if you're preparing for certification, take that spin on it, you'll want to know what the default settings of dial peer 0 are. We don't want to use dial peer 0, but if you do use it, I would know that little laundry list I rolled off to you right there. I hope this has been informative for you, and I'd like to thank you for viewing.